All right, let's go ahead and talk about half-life and radioactive dating. So, to begin with half-life, the first thing you need to know is that all radioisotopes, otherwise known as radioactive isotopes, have a characteristic rate of decay measured by half-life. One half-life, abbreviated T1/2, is the time required for half of the nuclei of a radioactive isotope to decay into products. And half-lives can be as short as fractions of seconds to as long as billions of years. So there's quite a large difference there. But what you need to remember is these radioactive isotopes have specific half-lives, and because they're specific and constant, you can use them to measure the age of different things. So let's look at one example that we're mostly familiar with, carbon-14 dating. So carbon-14 is an isotope of carbon, right, that has two more neutrons than carbon-12. The half-life of carbon-14 is listed right here. It is 5,730 years. Okay, so that would be the amount of time on this graph for exactly half of the original sample to decay into other products. After another half-life, you can see that you would end up at 11,460. And then this process continues, and you get fewer and fewer of the original sample. This is an exponential decay curve, and the way that this works is shown here in this video or in this diagram. So the sun emits solar radiation, electromagnetic radiation, that bombards nitrogen-14, and through a process called neutron capture, creates carbon-14. This carbon-14 exists in the atmosphere, and organic material like trees or animals or people, living organisms, absorb this carbon-14 and carbon-12 and the rare carbon-13 at different ratios, right? But they're specific ratios. When these organisms die, they stop absorbing carbon and they are preserved within the soil. And that ratio of carbon-12 to carbon-14 at the point of their death is the same. However, the carbon-12 is not a radioisotope, so it's stable and it stays the same. It's carbon-12. The carbon-14, however, starts to decay. And through the process of beta decay, carbon-14 turns into nitrogen-14 by emitting a beta particle. And the new ratio that you can find from a graph like this will tell you the elapsed time from the death of that organism. So that's generally how carbon-14 dating works. Again, here's another explanation of it in this video. Let's practice a couple of these. So how old is an artifact if 25% of the carbon-14 is remaining? Here's a hint. You don't need to memorize this. The carbon-14 half-life is 5,730 years. And another question, if the passing of 5 half-lives, so 5 half-lives, leaves 25 milligrams of strontium-90, how much was originally present? So we have two questions here. The first one is asking for an age, and the second one is asking for the quantity in grams, okay, of the original sample. So go ahead and pause this video, give this a try and then press play, and I'll show you the answers, how I work through them. Okay, hopefully you gave that a try. Let's go over the answers here. So, how old is an artifact if 25% of the carbon-14 is remaining? Okay, so 25%, this is the key part here. If you start with 100% of something, and then you divide it in half, you'll have 50%, and if you divide it in half again, you'll have 25%, correct? So that would be 1, 2 half-lives, and that's what's shown here. If you start with 100%, 2 half-lives have passed, so you take that 2 and you multiply it by the known half-life, which is 5,730 years, you'll end up with 11,460 years. All right? And the second one, if the passing of 5 half-lives leaves 25 milligrams of strontium-90, how much was originally present? So this one, you're working backwards, and instead of finding a time period, you're finding the mass. So we know that there's 5 half-lives. So we're going to take this number as our starting, and we're going to just double it. We're going to double it 5 times. Once, twice, 3 times, 4 times, and 5 times. And after those 5 half-lives, you can see that you originally would have started with 800 milligrams. All right. And the last thing, we're going to put it all together. This is a video that I suggest you watch. I'm not going to make you watch it here. Just pull up the notes and click on it. It's a really good video from Veritasium that talks about some practical applications of half-life that I think you'll find very interesting. And then, of course, I'd like you to do the practice, which is the next thing in the module. So thanks for watching, and let me know if you have any questions.